Welcome to Issues in Education. I'm Suzanne Smith. In the next half hour, we'll discuss the latest developments in higher education happening around the state and across the country. Joining me is my co-host, the Florida State University President, Dr. Eric Barron. The eyes of the country have been focused on the Deepwater Horizon oil spill in the Gulf of Mexico since April. Now the ears of the country are listening to experts at universities across Florida about what will happen next. 15 public and private universities have come together to be part of the Oil Spill Academic Task Force. Joining us today to talk about their roles on the task force are two of the experts, many experts, from the Florida State University. Dr. Felicia Coleman is director of the FSU Coastal and Marine Laboratory, and Dr. Eric Chassignet is director of the Center for Ocean Atmospheric Prediction Studies. Thank you both for joining us today.
You're welcome.
So when the oil spill occurred, the FSU faculty just jumped into action, and now we've ended up with this task force. Can you give us a little sense of what went on behind the scenes?
Sure. I mean, about a week into the spill, Dr. Ian MacDonald, who's a professor of oceanography, started to question the figure of the amount of oil that was generated by the spill, and questioned the 1,000 barrel per day figure that was put forward. So he approached the vice president for research in order to bring maybe together a few qualified scientists to discuss that issue. And that's what they did. And within that group meeting, it was decided that it will be that it was truly a question that needed to be further addressed, and that we should also ask our colleagues throughout the state for their expertise. So we started to put together a website, and then the provost approached the board of governors and talked to the chancellor, and who created this academic task force.
Did FSU take this role because we're so close to the ground zero of this, or was it just because of the special expertise here at Florida State?
It's because of the special expertise of Dr. Ian MacDonald that really spurred this into action, and his name has been all over the media, and I think we're going to talk a little bit in more detail about what he truly questioned and what is the estimate, his estimate or the estimates of his colleagues regarding the amount of oil that is being spilled in the Gulf.
But now, so the interest has expanded quite a bit, and so what areas of expertise is FSU drawing upon in order to support this effort?
Well, part of what we're trying to draw on at the Marine Lab and also across the university, but at the Marine Lab we're specifically looking at what are the ecological impacts of having oil come into the inshore environment, and but the importance is first placed on getting the baseline information. What are all these habitats and what are these organisms? How are they living and operating before there's something like an oil spill? What's the baseline information? And one of the things that we do, I mean, it's not just looking at the ecology, we're looking at the physical and the ecological things together. So we are working very closely with Eric and with researchers across the university and across the state now, trying to put together the right teams to address the problems.
Yeah, I mean, we have many physical oceanographers who are experts in the circulation within the Gulf of Mexico where the spill is occurring. And so not only we understand a little bit, the physics behind the currents and where the oil may go, but also we have powerful computer models that allow us to integrate some of the information and make predictions. That's one of our specialty at the Center for Ocean Atmospheric Prediction Studies.
So here are three issues that have now been brought up. Let's look at those in just a little bit more detail. How, so Ian MacDonald has become a leader in estimating the rate at which the oil and gas is coming out of the ground. And he had estimates that were larger at the beginning than anyone else, and it looks like he's been proven right. So perhaps you could explain how can he possibly estimate how much oil is coming out of the ground?
So there are two ways. I mean, the way he first started with was to look at the extent of the oil spill from satellite imagery, and then by estimating the amount of it that is what we call the light sheen, which is a very thin, few micron thick layer, to the more heavy crude, he provided an estimate in the range of about 20,000 barrels per day, which prompted BP to raise its estimate to about 5,000 shortly after. Then, working with other colleagues, they were able to obtain a live feed, a video of the oil gushing out of the well, and from particle imaginary, following the particles moving up, the estimates were ranged from 40 to 100,000 barrels per day. So I think the conventional picture right now is close to 60,000. There's a lot of uncertainties associated with it, but it's definitely an order of magnitude bigger than the 5,000 barrel per day. That is a common figure that is.
Once you know how much oil is out there, how can we tell where the oil is going to go? Is that in your expertise area?
Well, that's what we're trying to address. I mean, the picture is complicated by the fact that they are adding a large quantity of dispersant. So instead of the oil just simply moving all the way to the surface and then tracking where it goes to the surface, which is maybe a little bit easier to do now, we have to deal with a three-dimensional picture. And we really do not know what the effect of dispersant is, not on the oil. I think Felicia will talk more about the potential impact on the ecosystem. So we have to initialize our prediction system with accurate surface information, but also 3D picture. And that's been very limited. There have been a few ships out there, and we know it's there, but we don't even know the composition, if it's in droplets or big blobs, and where it is suspended in the column. And in order to have an accurate prediction, we need to have accurate initial condition.
So basically, the idea here is we have a current snapshot of what the ocean looks like.
Correct.
By knowing what it looks like today, you know the next step the circulation is going to take. And now, are you actually putting oil within that next step to try to predict where it will go?
What we have is ocean prediction systems that we have developed in collaboration with the Navy. Actually, it's a next generation operational system for the Navy. And let me maybe put a little bit bigger picture what the currents are in the loop. In the Gulf of Mexico, you have a major current that is called the loop current that enters the Gulf between Yucatan and Cuba, flows north, and then loops back south to exit between the Florida Keys and Cuba. Sometimes that loop extends very far north, like it did at the beginning of the spiel, or sometimes it can actually simply go from the Yucatan to Cuba when it sheds itself off a ring. It's just a big blob of warm water separates and moves westwards into Texas. This is actually what's happening right now. The loop current is forming a ring that may or may not separate. Sometimes it may reattach in time. So what our ocean predictions system consists of a high-resolution computer model. I mean, with a few, maybe about a mile or two mesh, and we combine in situ observation as well as satellite observation to determine the position of the current position of the loop current, and then we let the computer model take over and make a prediction. So once you have that, you have currents, ocean currents. Now the oil is going to move. It's going to depend on a lot of factors. It's going to depend also on the wind, and it's going to depend on the nature of the oil that you have, and the waves and the tides. We are not oil spill experts, and I think that's been my personal estimate. It's been the realm of private companies working with the oil companies. It's not been a very heavily topic of research among universities. But what we can do, there are several simple models out there, and that's what we did, that combines the effect of wind and currents together. So we initialize the extent of the oil spill based on the maps provided by NOAA or our colleagues, and then combine wind and current to make the prediction. And we do that daily and make it available on the Oil Spill Task Force website.
This program is going to start airing June 2nd, which means we're going to be at the beginning of hurricane season. How will the hurricane change this up?
Well, that's a big question. I mean, something, at the center we are hosting Dr. Mark Powell, who is a NOAA Hurricane Research Division NOAA scientist from Miami, is permanently with us. We have also, we're doing seasonal prediction as well as looking at the impact of air-sea interaction on hurricane prediction. So that's been a topic that's been discussed a lot. There are The first question is, how is the oil going to affect the hurricane development? And that's something that's not very well known. The fact that you may absorb more heat in the ocean due to the sheen, the fact that waves may not break as fast, therefore, again, heat dissipation. So all the mechanism that actually makes the hurricane so strong may be affected by this. Then the second question is, where is the oil going to be? Going to go, and either it can be pushed obviously on shore, and then you have to think about storm surge and where it may go and how it's going to affect the water and anything to do with hydrology in that area. Then the other thing is that it could also move some of the oil offshore, and what we mean by offshore is how likely it is going to be captured by the loop current. And if it is captured by the loop current, it could move very quickly away from its source and could be advected all the way to the east coast of Florida and affect Cuba, the Bahamas. Or it could be trapped in that big eddy that I was talking a little bit about, and then move westward and affect Texas and Mexico. So it could potentially have some impact over a much wider area than what we have right now. The big unknown is how well the oil is going to disperse or evaporate within a storm like this. You could actually accelerate the weathering of the oil and make it less.
The third major topic that we talked about that you introduced was the impact on the biology, which of course gets a great deal of attention. What's the significance for fisheries? What's the significance for marshlands and other habitats?
Well, let's start with fisheries, because there's sort of two elements of that. One element is has to do with the fisheries themselves, so that's partially an economic question and a biological question. And the other is seafood safety. And the only comment I'll make about seafood safety, because that's not my area, but NOAA is trying to be very conservative in terms of having seafood introduced in the market that's not safe. So they've closed enormous areas of the Gulf of Mexico already, even in areas that clearly have no oil in it. This is devastating right away to the fisheries, just on a pure economic basis. But ecologically, it's a problem. When you think about it, the oil is in the surface, in the surface water, and many of the species that we depend on for fisheries are spawning now, and the eggs are floating up into the surface water. So they're getting. You can have a really devastating impact on the next year class of fish by having them just wiped out there. Kind of the wild card that's been thrown in is dispersants, because there's a trade-off here. You're trading the visibility of oil inshore with having it distributed as small droplets throughout the water column, and in fact reaching the seabed. So then it looks like food to small animals that live out there. So they're eating it. Larger animals are eating them. So you're getting these, hydrocarbons and all other sorts of components that are going up through the food chain that way, so they can have an impact by accumulating as the toxins move through the food chain. But you also have an effect of it going through the water column and coming down on the bottom, where a lot of these animals spend part of their lives, of important fishery species live in sponge and coral communities. You're completely devastating these communities. And then when it comes inshore, and I need to back up 1 second, because we're talking about animals that have complicated life cycles. They don't just live in one place. Their eggs and larvae are in the surface. They may have a juvenile stage of their life, like many of the grouper do, in seagrass beds or in salt marshes, and then they move offshore. So they're potentially impacted at every stage of the life cycle. That can be devastating, because it's wiping out stages that can wipe out year classes that can affect the fisheries for a number of years. And one of the questions was, what is the recovery time? We really don't know. It could be decades, because again, even if when you're killing the larvae, you're killing 1 year class. If you're wiping out their habitat, that's a much longer term effect.
I want to make sure that we don't just sit here and think about the predictions and the impacts. but also discuss whether this university in this state is really ready to do this type of work. And maybe, this isn't the only issue, and the coastal ocean is probably more important to the state of Florida than any other state that you can think about. If you were to design the research teams that would really serve the state of Florida well, what should a Florida state look like?
Well, first, let me say one of the problems for this region where the oil spill is occurring is this is one of the most pristine areas left in the country, certainly along Florida's coast, and it's also woefully understudied. That led, in part, and NOAA, I'm guessing, had some foresight here, in the development of the Northern Gulf Institute, which is a collaboration among universities throughout the Northern Gulf. So that kind of sets up, already set up 5 years ago, a group of people who are trying to get baseline information about this whole region. But one of the things that the oil spill has done, I'm not sure if it changed the features of what we are studying. What it changed was the priority. And so certain things come up to the surface that weren't there before. Toxicology, for instance, that might not have been completely on our radar screen. There are a lot of toxicologists, but it became much more important. Another area is economics. And not just what is the seafood industry valued, but what is the interaction, what are the ecological impacts, the behavior of the fishermen, and how do they operate their fishery? So.
Eric, do you want to add to that?
Things that we
Yes,
change.
I mean, one of the things that our participation within the Northern Gulf of Mexico Cooperative Institute has shown is how important the interaction between the physical oceanography, the ocean currents, and biology is. So that's one area that needs to be strengthened. My personal vision, biased a little bit by the fact I'm director of the Center for Ocean Atmospheric Prediction Study, is an Earth system modeling prediction system where we would have ocean, atmosphere, current, tides, oil spill, biogeochemical modeling, and fisheries all together. That would allow us to have a better idea of the connectivity between the various components and its impact. I think this university needs to move away from the impact of the budget cuts on the oceanography group, and needs to be able in the future to rebuild and strongly build its faculty and its expertise in the area.
Let's make sure we're direct about this. Florida State now, with this recent cycle, has lost $84 million. One of the areas that was the hardest hit was oceanography. And so have we lost significant capability in the very areas that the state should be keenly interested in?
Yes, we have. I mean, we have lost so many experts on tides, and that would have really, and prediction, that would have really helped us to understand a bit better on the impact of tides on the oil spill. And maybe you can, Felicia, emphasize a little bit on the other loss.
Well, I mean, we've lost areas in benthic ecology, and the Marine Lab itself has felt some of the budget cut and not being able to fill positions that we had right at when we were just starting out a new program, and so that's been devastating.
So benthic ecology, the organisms that are living on the bottom,
yeah,
that now we're going to feel the brunt of this.
Certainly will feel the brunt of it.
And so, one last question here on this particular topic. Are we about to transform what students study?
That's a hard question to answer. I suspect that what will happen is more students will be interested in hazards. And particularly these anthropogenic hazards. We've always had a lot of interest in hurricanes and marine biology in general. I mean, if you look at the people that apply to biology departments, it's remarkable how many marine biologists, how many students would like to be marine biologists or go into oceanography. one of the things that I've seen change over the last 10 years, and this is kind of an indirect way of getting to your question, but students, it's not that they don't want to do esoteric work. They want to do work that matters in a social context. What does it mean for the rest of us? So they really are interested in trying to help solve environmental problems. And I've seen that go on for quite some time in our undergraduates, among our undergraduates, and among the graduate students as well. I think this kind of thing just bubbles it up to the surface and makes it much more obvious. And it may help students pick out a particular area they'd like to work in.
Well, this also, puts forward is a little bit, we have a new degree in environmental science. And what this really exemplify the interconnectivity between the discipline, truly interdisciplinary. Transport currents often were studied on the side. We have started to work together with fisheries, but this is another medium that affects not only fisheries, the transport, everything that is likely to interest a lot of students, and this new degree is one possibility for them to be exposed to that.
And we actually have another one in the chute that we're working on, which is marine science, conservation, and policy, which is really, it's an area that's near and dear to me, because I think one of the other things that's really important and more people are paying attention to is that we get the funding for our research from federal and state agencies. I think we have an obligation to make sure that the good science that we're producing is informing the policy that comes out. And there's some gaps right now. I think that's obvious by what just happened in terms of environmental impact statements and things like that. There's a real opportunity to build a cadre of new scientists who are really looking at that closely.
Let me state also that the main purpose of putting this task force was actually to assemble expertise throughout the state of Florida.
Yeah.
And one of the things that we have done is create an expert database that would allow the state officials or concerned parties to truly be able to identify what and who can address.
And that's at oilspill.fsu.edu. Okay, thank you both for joining us. We've been talking with Felicia Coleman and Eric Chassignet, members of the Oil Spill Academic Task Force. We're going to take a quick break. When we come back, Dr. Barron and I will talk one-on-one about more issues in education.
This is not a university presidency. This is the opportunity to take the Florida State University to the next level.
We're attracting a student body that can go off and do great things.
I like to get the job done. That's really what I'm about.
Welcome back. I'm Suzanne Smith, sitting with Dr. Eric Barron, the president of the Florida State University. Dr. Barron, we've been talking about the Oil Spill Academic Task Force. Why is it so important for this force to be created and FSU to participate in it?
Okay, well, one of the things that's the most important to me, and I think it's a real message, is that this isn't someone sitting around in my position saying, let's organize this, let's do this. This is our faculty with their expertise and ability to engage with a problem that's important to the state and to the nation, and they're stepping up there to use their expertise to help us. And in my view, that means the institution and the other institutions around the state need to step up to help them and to add that flavor of a task force or institutional endorsement. But led by faculty from their expertise, that's exactly what you want.
Members of the task force headed to Washington last week of May to talk with Congress about the oil spill. How critical is it to have that kind of dialogue between researchers and legislatures?
Well, I can't tell you how many times that you see policy over here and people that focus on a budget, and there's a filtering of all the knowledge that leads up to that policy. So anytime you can put real experts in front of the policymakers, you're a step ahead. And so having the magnitude of the oil spill is a perfect example. Our faculty were saying this is bigger than what's being reported. And they knew it, and they knew why. And so to make that connection makes a huge difference.
You actually did some work when you were an undergraduate in the Gulf that's sort of related to this. What was that?
Well, this was in Escambia Bay, and Escambia Bay was one of the biggest oyster producers in the United States. And there were a whole series of chemical plants that were upstream, and they were putting a number of chemicals into the water, and we lost this productive ecosystem. And so the project was, what would it take to get it back? And so in some ways there's some parallels there. But I was an undergraduate with graduate students and with faculty, invited to go on a couple of research cruises, to take cores, look at the current structure in the bay, and make recommendations. And it's interesting because I just spent a full day in Pensacola talking with our alumni, and one of the big problems was the railroad bridge and the pilings. And I hadn't seen it in 30-some years, but it's gone. The big barrier to the circulation is gone. And so each step of the way, we do what we can to improve the environment.
Do you think the oil spill and the subsequent research is going to actually help FSU and other Florida universities get more research funding?
Okay, so here's really the issue. We already know it's underfunded. And one of the things that you see right now emerging out of the federal government and interest in states is to regionalize our science, to bring the science close to specific problems. And we haven't been doing this. And the Gulf is this magical area that should have this highly developed research focus, and we haven't had it. And so, in my mind, it's been underfunded. And I don't like tragedy, but it is a call for action when it comes to research.
Thank you, President Barron. That's our time for now. Please join us again next month for more Issues in Education. You can watch the premiere episode of Issues in Education the first Wednesday of every month at 7:30 p.m. That means you can see the next new episode on Wednesday, July 7th on WFSU TV. Join us as we discuss the latest developments in higher education happening around the state and across the country. If you have questions that you would like us to address on this program, you can email us at issues@wfsu.org. Again, that's issues@wfsu.org. If you would like to see past episodes of Issues in Education, head to the President's website at president.fsu.edu. I'm Suzanne Smith with the Florida State University President, Dr. Eric Barron, for Issues in Education. We'll see you next time.